This pie chart shows how the children in Class 6 best like their potatoes cooked. 32 children took part in the survey. For each statement, put a tick if it is correct. So our first statement, 10 children like chips best. Now what I would do here is to draw lines across so that our pie chart is split into equal pieces, and then we can see that we have 8 pieces altogether, and 2 of those pieces are for chips. So 2/8 of the children like chips best. There are 32 children, so we can find 2/8 of 32, and that will tell us how many like chips the best. To find a fraction of a number, we divide by the denominator, and 32 divided by 8 is 4, and then we take that answer and multiply it by the numerator, and 4 times 2 is 8. So 2/8 of 32 is 8, not 10, so this statement is incorrect. Now, 25% of the children like mashed potatoes the best. We can see that the section for mashed is 2 parts out of 8, but a percentage is a fraction with a denominator of 100. So we need to change 2/8 into hundredths. But 100 is not in the 8 times table. So what we can do here is simplify our fraction first. If we divide both the numerator and denominator by 2, we can see that 2/8 is the same as 1/4, and we can change quarters into hundredths. 100 is a multiple of 4 because 4 times 25 is 100. What we do to the denominator, we do to the numerator as well. 1 times 25 is 25. So because we know that 2/8 is equivalent to 25 hundredths, we know that this statement is correct because a percentage is a fraction with a denominator of 100. Now, 1/5 of the children like roast potatoes best. We can see that roast potatoes is this section here, but that's 1 part out of 8, so 1/8, not 1/5, so this statement is incorrect. And finally, 12 children like jacket potatoes best. We can see that jacket potatoes covers 3 parts out of 8, so 3/8 of our pie chart, and because there are 32 children altogether, we can find 3/8 of 32. Remember, we divide denominator and times top. 32 divided by 8 is 4, times 3 is 12, so this statement is true. This is the scale on the side of a measuring jar. There is some coloured water in the jar. How much more water is needed to make 2 litres? So we have 2 litres on the top, we have 1 litre marked, and then each of these little lines must be 100 millilitres because we have 5 lines to get to 500. So that's 100, 200, 300 millilitres above 1 litre. So what we have is 1 litre 300 millilitres or 1.3 litres. But the question does not ask how much do we have. It asks how much more water is needed to make 2 litres. Now 2 litres is 2000 millilitres because there are 1000 millilitres in a litre. So if we subtract 1300, because 1 litre 300 millilitres is 1300 millilitres, that gives us 700. And the reason we're subtracting here is that the question asks how much more, so we know that we're finding the difference. So our answer is 700 millilitres. We could also give our answer in litres. If we have 2 litres, so that's the same as 2.0, and subtract 1.3, that gives us 0.7. So we could write 0.7 litres as our answer as well. Write the correct sign greater than, less than, or equal to in each of the following. So here we have calculations with brackets, so we need to remember that we always do what's in the brackets first. So here we have 10 plus 5, so 15, minus 9 is 6. And here we have 10 plus 9, so that's 19, minus 5 is 14. 6 is less than 14, so we need a less than sign. Now 3 times 4 plus 5, but 4 plus 5 is in brackets, so we need to do that first. 4 plus 5 is 9, and 3 times 9 is 27. Now we have 3 times 4 in brackets, so that's 12, plus 5 is 17. So 27 is greater than 17. And now 10 times 4 is in brackets, so we do that first. 10 times 4 is 40, and 40 divided by 2 is 20. Now here it's 4 divided by 2 in brackets, so we need to do this first. 4 divided by 2 is 2, and 10 times 2 is 20, so we need an equal sign because we have the same value on both sides. There are 12 points marked around this circle. The points are equally spaced. Join 4 points to make a square. So we need to remember that the sides of a square are the same length. So we need to leave the same amount of space, so the same number of dots between each of our corners. So we have 12 points altogether, and we need to join 4 of them. 12 divided by 4 is 3, so that tells us that there will be 3 points from one vertex to the next, so from one corner to the next corner. So we can pick any of our points to start with, and then we can count 1, 2, 3, 1, 2, 3, 1, 2, 3, and then when we join up our points, we can see that we have the same amount of space. We have 2 dots between each of our corners. So we know that our sides are of equal length, which means we have a square. The square doesn't have to look exactly like this. As long as you've got 2 dots between each of your points, then you've got the right answer. Write in the missing numbers. 1 is done for you. So we have 0.321 equals 321 over 1,000. And that makes sense if we remember our decimal place value. The first digit after the decimal point is the 10th digit. The second digit after the decimal point is the hundredths. And then the third digit after the decimal point is the thousandths digit. So because there are 3 digits after the decimal point, that tells us that we need a fraction with a denominator of 1,000. Then we can look at the digits we have. We don't need to write 0 in our numerator, but we have 321, so that's 321. Now we have 2.433. We have a denominator of 1,000 because we have 3 digits after the decimal point, and the third digit is the thousandths digit. But this time our ones digit is not a 0, so we need to include the ones digit in our numerator, so we have 2,433 over 1,000. And it makes sense that we have an improper fraction, because remember, improper fractions are greater than 1. Improper fractions, we have a larger numerator than denominator. And that makes sense because we have a decimal greater than 1 as well. So now we need to write the decimal for 457 over 1,000. The denominator of 1,000 tells us that there will be 3 digits after the decimal point, so that's 0.457. Because we can only have one digit in each place value, the 5 gets pushed over to the hundredths column and the 4 gets pushed all the way over to the tenths. And now, what decimal is equal to 23 over 1,000? Again, the denominator of 1,000 tells us that we need 3 digits after the decimal point, so that's 0.023. Again, we can only have one digit in each place value, which means the 2 gets pushed over into the hundredths. But to show that this 2 is in the hundredths and this 3 in the thousandths, we need to write a 0 as our tenths digit, because that gives the other digits the correct place value. Here are two shapes made with centimetre squares. Each shape has 5 squares. Write one other thing which is the same about the two shapes. So we could have they are symmetrical, because we can draw lines of symmetry so that the same is reflected on both sides. And this shape here, in fact, has more than one line of symmetry. You might spot that we could also have a horizontal or diagonal lines of symmetry. Or we could have they have a perimeter of 12 squares. Remember, the perimeter is the distance around the outside of a shape. So if we start here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we start here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could also write that they have the same area, because remember, the area is the amount of stuff that's inside a shape, and they both contain 5 squares. Liam has 2 rectangular tiles like this. He makes this L shape. What is the perimeter of Liam's L shape? So remember, the perimeter is the distance around the outside of the shape. So what we can do is label the sides that we know. We have 3 shorter lengths, and we know that the shorter length of the rectangles are 5 centimetres, and we have 3 longer lengths, which we know are 11 centimetres each. But we also have this length here. Now this isn't necessarily going to be the same as the shorter length. But notice, we know that this length at the top is 5, and that this length at the bottom is 11, and 5 plus our missing length is the same size, the same length as 11. Now 5 plus 6 is 11, so we know that this missing length here must be 6 centimetres. So now to find the perimeter, we can find the distance around the outside. We have 3 lengths of 11 centimetres, and 3 times 11 is 33. We have 3 lengths of 5 centimetres, and 3 times 5 is 15, and we have 1 length of 6 centimetres. So the perimeter is the total length around the outside, so we can add those lengths. 33 plus 15 plus 6 is 54, so the perimeter of Liam's L shape is 54 centimetres. Here is part of a number line. Write the 2 missing numbers in the boxes. So we need to know what each of these little lines represent. Now to get from 960 to 980, we have 1, 2, 3, 4 lines. Now the difference between 960 and 980 is 20. 980 is 20 more than 960. And because our difference was 4 lines, if we divide that by 4, that will tell us what each of these lines represents. 20 divided by 4 is 5, so each of these little lines represents an increase of 5. And that makes sense because from 960 we have 965, 970, 975, 980. Now this point here is one line before 960. So that will be 5 less than 960, so 955, because 960 minus 5 is 955. Now let's find this box here. We have 980, 985, 990, 995, 1000, 1005, and then this line here must be 1010. Here is a sorting diagram for numbers. Write a number less than 100 in each space. So on this side we have a square number and not a square number. So we need to remember that a square number is what we get when we multiply a number by itself. And then at the top we have even and not even. So an even number ends in 0, 2, 4, 6 or 8, because an even number is a multiple of 2, or a number in the 2 times table. So for this box here, we need a square number that is also even. So we could have 4 here, because 2 times 2 is 4, so it's a square number and it's an even number. But there are lots of other possibilities as well, as there are for all of our boxes. Now here we need a square number that is not even. So we could write 9 here, because 3 times 3 is 9, so it's a square number, but it's not an even number. Here we want a number that is not a square number, but is even. So we could have 6 here, because you can't multiply a number by itself to get 6, but it is an even number. And now we want a number that is not a square number and not even. So we could have 7 here. It's not a square number because you can't multiply a number by itself to get 7. And it's not even because even numbers always end in 0, 2, 4, 6 or 8. Fill in the 3 missing whole numbers in this calculation. Each number is less than 10. So something times something times something equals 105. So because we have a missing number multiplication, we can use division to find our missing number. 105, if we divide it by 2, will give a remainder. So let's try dividing 105 by 3 to see if this number here might be a 3. We can use short division and we get 35. So 35 times 3 is 105. So if this number here is a 3, then our other 2 numbers will need to give a product of 35. And 7 times 5 is 35. So our numbers could be 7, 5 and 3. 7 times 5 is 35, and then we know that 35 times 3 will be 105.